Here we're going to continue solving right triangles using trigonometry, but these particular cases we're going to need inverse trig functions to do this. So, just to recap what an inverse trig function means, and it's probably easiest to do in terms of the trig functions. Trig functions, we input angles, sine of theta, cosine of theta, secant of theta, things like that. And they output ratios. In this particular case, ratios of side lengths, opposite over hypotenuse, hypotenuse over adjacent, things like that. Based on that, inverse trig functions will input those ratios and output the angles. And those are really useful when our angles are missing and we cannot use other methods to figure out those angles. So this is where we're going to focus on just one problem here on using inverse trig functions, and that really does rely on the calculator as well. So our first example, solve the given triangle completely, meaning find all the remaining sides and angles. So once again, it's going to be a right triangle of some nature. That will be my angle gamma, my 90 degrees. The side C will be opposite my 90-degree angle. And the side B, it doesn't matter. I could label it whichever side I want. So I'm going to call that 19.67. That will be my B. Once I've done that with B, however, that forces this angle to be beta, this angle to be alpha, and this side to be A. And those are the three things I need to find. Probably easiest to find is side A first, and I can use the Pythagorean theorem. And what I'm going to encourage everybody to do here, in the interest of thinking about some of our scientific applications with sig figs and percent errors, is to not put anything into the calculator until we get to a final expression. Put into the calculator as one large expression. So here I would have a squared plus b squared equals c squared for my hypotenuse, my Pythagorean theorem. A squared is what I'm looking for. B squared, 19.67 squared. C squared, 37.21 squared. Now, instead of putting any of this into the calculator, I'm going to rewrite it as 37.21 squared minus 19.67 squared, just subtracting that from both sides. And understand that I'm going to need to take the square root of both sides. And 37.21 squared minus 19.67 squared. And now that I've isolated that A, and I haven't put anything into the calculator yet, I've avoided rounding on top of rounding on top of rounding. And I can go ahead and put this directly into my calculator here. So give me a second while I do that. And we will get 31.6 approximately. And let's see, we had a label of centimeters on there. So there's our value of A. We've got our value of A. We need beta and alpha. In our previous examples, if you'd watched the other video, we used the fact that the angles of a triangle add up to 180. We can't use that here because we don't have two angles. We only have one angle. But I can use trigonometry. Where I'm going to go with this particular problem is I'm going to look at my angle alpha. I'm going to look at my angle alpha and recognize that I have the 37.21 and the 19.67, the side that is adjacent and then the hypotenuse. So that makes me think of the cosine function. So cosine of alpha defined as adjacent over hypotenuse. And now is where the inverse trig function would come into play, that I can rewrite this as the inverse cosine of 19.67 over 37.21 equals alpha. And so what I have here is that inverse trig function where my input is a ratio and my output is going to be an angle. Now this is most definitely a calculator exercise to get alpha equals. Make sure your calculator is in degree mode. We get approximately 58.1 degrees. Now, when it comes to finding angle beta, I could do 180 minus 90 minus the 58.1, and that would work. But we're here to practice trigonometry, and the other thing is that the 58.1 is a rounded angle, but not a big deal. But I think maybe we should take a moment here and practice our trig a bit. And so, looking at my beta, I have the side that is opposite. I have the hypotenuse. It makes me think of the sine function. Sine of beta 19.67 over 37.21. Create the inverse sine function where I will input the ratio 19.67 over 37.21 to get out my angle beta. Becomes a calculator exercise. And I will have inverse sine of 19.67 divided by 37.21. And my beta is approximately 31.9 degrees. So I got my label on it. So my task was to find alpha, beta, and A. I've got alpha, I've got beta, and I've got A. And so that's just kind of how we would use inverse trig functions to find missing angles on our calculators. Hope you found it helpful in doing whatever you're doing in class. Thank you.